Welcome to Effortless Math Channel. Today, we're going to be learning how to graph trigonometric functions by first determining the coordinates and then plotting points on a grid. The first thing to note are the different types of trigonometric functions. The three main ones that are traditional, in a sense, are cosine, sine, and tangent. However, we have another set of functions, which are secant, cosecant, and cotangent, which are all reciprocals of the previously mentioned three trigonometric functions. So first, let's start with the domain. We want to begin by creating a table that looks like this: left side x, right side y. And for all of these trigonometric functions, we want to have a basic range of -2 pi to 2 pi. And we'll figure out just where it is that each of these functions differ in their exact domain corresponding to each graph as we fill in the table. So these are also what each of the radian values are equal to in degree measures. So you can interchange between the two. However, what's key to note is when you are graphing, only use radians on the grid. Now, again, as mentioned, it may be easier to use degrees depending on what it is that you feel most comfortable with. However, use radians on the grid when you're graphing. So for each x value, you'll go ahead and plug that into the graph in order to find y. So let's start with the graph y equals cosine of x. You can use either your calculator. For the calculator, it would be best for you to plug in the degree measure. Make sure that your graphing calculator is set to degree mode so that you get the right value. And if you're plugging in a negative degree value, make sure to include that negative because that'll change your answer. If you're going by radians or even degrees, the other thing that you can do is you can also memorize this pretty nifty chart right here. This chart has a list of all the values that when you plug in these degree measures, you get those y values. Now, these values will differ depending on if they are positive degree or radian measures or negative degree or radian measures. So let's start with the example cosecant of x, which was mentioned previously as being a reciprocal of sine of x. So we already have our domain marked out from -2 pi to 2 pi, aka -360 degrees to 360 degrees, and we have our chart in the top right so that we can refer to it whenever it is that we need to. The other thing to note, again, it is a reciprocal. So if you're plugging in by hand your x values, then you can go ahead and put in -2 pi to start. And you'll put that in, and what you'll end up with is 1 over sine of -2 pi. When you solve that, you'll end up with 1 over 0. This is an undefined value, and that means that there's an asymptote at this point. So what you can do is at this point you can mark with a red line or any color line depending on whatever form of writing utensil you're using to show that the graph never touches this point. And this is demonstrated here. Now, go ahead and keep going through each x value. Plug it in order to determine what the y value is. In this case, we get 1 and plot a point. And keep on doing this for each of the values. So for this graph cosecant x, we end up with a series of vertical asymptotes as well as points that we plot. Now again, keep on filling in until you get to the very rightmost part of the graph, the rightmost part of your domain. Now it's unclear just how to draw the graph, how to draw the curves within each of these asymptotic domains. For example, between -2 pi and -pi, which means that we probably need to fill in more x values so that we can determine how to draw our curves. Therefore, we can add more values to the table, and this we learn by practice. So for example, you can plug in 60 degrees, which we can convert to radians as being pi over 3. When we plug that into cosecant of x, which we would plug into 1 over sine of x, then the y value that we will get is 2 times radical 3 divided by 3. And that point is plotted right over here. You can also plot the point negative 60 degrees into x, and we will get negative 2 times radical 3 over 3. You can do the same thing with the values 45 degrees, 30 degrees, and whatever else it is that falls in between these asymptotes. However, it's not necessary to do so because based on what we know about trigonometric graphs, they are cyclic. And so once you go ahead and know what the pattern is, you can fill in anything that's remaining. So again, we started off here. We had our missing points that helped us to fill in things from before. And then once we see this pattern, we can fill in everything else, just like this. Now, just to wrap up, today we learned how to graph trigonometric functions. We learned how to determine coordinates to a more complex function, cosecant x, and learn how to graph those functions. Cosecant x is not the only one of those trigonometric functions that has asymptotes. There's also secant of x. There's also tan of x and secant of x. However, cosine and sine are much more straightforward. I hope that going through these more complex functions makes it easier to get through the others. Thank you again for watching Effortless Math Channel.